Core drilling, or also called diamond drilling, is a type of fast rotation drilling, the implementation of which results in the destruction of the rock within a ring pattern, but not over the entire bottom hole. In this mode of drilling, the interior of the rock in the form of core, a rock pile with an undisturbed structure, is fully preserved. For this purpose, the core is periodically locked and isolated from the bottom and lifted up to the surface using a core receiver suspended on a rope, from which the core is removed and distributed to core boxes. RC drilling, or also called reverse circulation drilling, is carried out using the air supplied through the rods with a reciprocating piston, a so-called air hammer, used as the drilling mechanism rotating the drilling bit made of tungsten steel. When pressure is applied to the rod, an aerodynamic lift is generated by means of which the water rises up the annular space with the sludge rising within the inner tube, which is located inside each rod. Ideally, in the course of RC drilling, we obtain dry drill cuttings, since the compressed air from the compressor dries rock in front of the drilling bit. The cuttings reach the reflector on the rig mast, move through the sampling hose and into the cyclone, followed by processing within the cyclone until released through the opening at the bottom, whereupon collected in a sampling bag. For comparison, during the drilling method with direct blowing, which is mainly used for the blast hole drilling cuttings, reach the Earth's surface using the same air pressure, but through the annulus, where the sample is naturally contaminated. The most commonly used drilling bits for RC drilling have a diameter of 124 to 130 millimeters, with protruding round metal buttons or pins. If we use in diamond drilling the average size of 95 millimeters, the core diameter is about 63 millimeters. Thus, comparing RC drilling and core drilling by the sample amount, RC drilling is characterized by the obvious superiority. It is also worth noting that unlike air hammer drilling, core drilling provides geologists with the opportunity to visually analyze samples, since an undisturbed core structure provides a complete picture of the structure and rock occurrence. When exploring at shallow depths, RC drilling can be used independently without the aid of core drilling. When exploring to a greater depth, RC method is used as a cost-saving method of drilling in order to reach mineralization. After that, geologists may decide whether to continue RC drilling to extract cuttings or go shift to core drilling for the extraction of the core. In this case, RC drilling becomes a great addition to the normal core drilling. Due to a number of the factors mentioned above, RC drilling method is cheaper than core drilling, and therefore it is preferred in the exploration of mineral resources. The choice of method used in the exploration and assessment work depends on whether drilling is performed from the surface or from mines, on the geological features of the deposit, hole depth, the complexity and the category of drillability of rocks, as well as preferences of the geologist. Modern coring rigs allow for fast and efficient coring to a sufficient depth from holes of different diameters. At the same time, RC drilling has become so progressive and advanced that more and more geologists believe that to determine the mineral composition of rocks, RC cuttings are enough. Taking all the aforesaid into consideration, we should say that drilling from the surface offers a choice of cuttings, core, or a combination thereof. Underground RC drilling is certainly technically possible, but until now has been used to a very limited extent.